Okay. So, if two people are applying a force of 200 Newton, then what is the force applied on this rope? 200 only. 400 is not correct. See, on this rope, two people are applying forces. This is 200, this is also 200. So what is the net force? So which force is responsible for producing elongation? Net force is 0. How much force is responsible for producing elongation? Is it 200 Newton force or 400 Newton force? Huh? 200 Newton is the force which is responsible for elongation here. What is the reason? Sima. For example, if this is the rope, and if I force apply here with a force of 200 Newton, then same force will be applied on the roof also, no? It means roof is also applying a force of 200 Newton. So on both sides, force should be equal and opposite. Then only elongation is possible in any wire. So here net force is how much? Only 200. So therefore, what is my answer? So Y is equals to F into L divided by A into delta L. What I am supposed to find out? Young's modulus. So force is how much? 200. Length is 2 meters. Area of cross section 2 centimeters square. So 2 into 10 power 4 meters square. Length. Elongation is how much? 1 centimeter. So 1 into 10 power minus 2. So this is our answer. Clear, ma? Length is how much? 2 meters, huh? Okay. So therefore, 200 into 10 power 4 into 10 square. So 2 into 10 power 8 Newton per meter square. That is our answer. That's all. Okay. So here there is a steel rod which is fixed between two clamps here. Understand? Then what is its area of cross section? Area of cross section is 4 centimeters square. So its length is tending to decrease by 0.1 centimeter as temperature has decreased. Clear? So if rod is clamped between these two supports, then find the tension developed in this rod if this is the Young's modulus. How can I calculate? Come on. Sima, if temperature decreases, automatically length of this rod will reduce, no? So if rod reduces, what will happen? This rod, it tries to pull these clamps also, these supports also. So because of this pulling, a force of tension will develop inside this rod. Then how can I calculate that tension? By using which equation? Same equation. Y is equals to F into L by A into delta L. So here some force is responsible for producing strain in this rod, no? And what is that force? Tension. Tension is responsible, no? So therefore, how can I write? T is equals to YA delta L divided by L. So Young's modulus is how much? 1.9 into 10 power 11. Area of cross section 4 into 10 power minus 4. Change in length 0.1 into 10 power minus 2 meter. Original length is how much? Original length. Length of this rod is how much? 2 meters. Length is given as 2 meters. Clear, ma? So do this calculation, that will be our answer. That's all, no? So the answer which you should get is 3,800, come on, 3,800 newtons. That's all, no? So if temperature decreases, automatically length reduces, no? So if there is no clamping here, then tension will not develop in this rod. Okay? But if it is try to reducing its length, then it will pull these clamps also, no? It means the clamps are pulling this rod in opposite direction. So because of this pulling, tension will develop inside this rod. Okay? So that's our answer. So question is like this. if a stress is this much, then this steel will rupture. What is meant by rupture? This will break down, this will bend, whatever it may be. Clear? So find the shearing force necessary in these two conditions. First, shear a steel bolt 1 centimeter in diameter, and next punch a hole of 1 centimeter diameter in steel plate of 0.5 centimeter thickness. Okay? So it means if I apply this much of stress on this steel, it is going to rupture. It will change its shape. Okay, its dimensions will change. Then in these two conditions, I want to calculate the force necessary to shear a steel bolt. Similarly, to punch a hole of 1 centimeter diameter in a steel plate whose thickness is 0.5 centimeter. Clear? Think how you can do this one. Any idea how can I solve this one? Okay. So what is the first one he is asking? So he want to shear a steel bolt 1 centimeter in diameter. Shearing means changing shape, no? Shearing means changing shape. For example, if this is a steel bolt, clear ma? I have to apply force here. Tangential force I have to apply. To change the shape, what kind of force I have to apply? How many kinds of forces are there? Normal force, volumetric force, and shearing force. So to change the shape, always I have to apply tangential force. Clear, no? So it means the force I have to apply in this direction, then I can change the shape of this steel bolt. Are you able to understand? Then what I am supposed to find out? I am supposed to find out force. How can I calculate the force of this one? So is Young's modulus of this one, is it given? No need. So here stress is given. So stress is how much? Stress is nothing but force per unit area, no? So stress is equals to 4 into 10 power 8 Newton per meter square. Clear, ma? I am supposed to find out this force only, no? So therefore what is F value? F is equals to 4 into 10 power 8 into area. Now the question is, what is meant by this area? Which area I have to take? Top surface area I have to take. Because in shearing, already we discussed, no? We are supposed to take that area to which a force is tangential. Are you able to understand, ma? And what is the diameter of this bolt? 1 centimeter. Then radius will be how much? Radius will be 0.5 centimeter, no? Then can you say what is the area of that bolt? Area formula. Diameter means this is in the form of a circle, no? Area of a circle? Pi r square. So therefore area is equals to pi into radius is how much? 0.5 whole square. So 0.5 divided by 100 whole square. So this is the area. Clear, ma? So then just substitute in this relation, then that is our answer. So what is the force? Force is equals to 4 into 10 power 8 into pi into 0.5 divided by 100 whole square. Clear, ma? So if you calculate this value, what is the answer we have to get? 3.14 into 10 power 4 Newton. That is our answer for the first one. Clear? Now what about second one? Second one, so there is a steel plate. So consider this is a steel plate. And what is the thickness of this plate? Thickness of this one is 0.5 centimeter. So in this steel plate, I want to punch a hole. Clear, ma? I want to apply some force and I want to punch a hole into this one. Then how much force I have to apply? That is the question. Again, concept is same, no? Stress is equals to force per area. Force is equals to stress into area. So let us write the same relation. So force is equal to stress into area. So force is equals to stress value is how much? 4 into 10 power 8. Now the question is, what is the area on which I have to apply this force? 2 pi r becomes only length. Clear, number? So 2 pi r only becomes length of this one. So to punch a hole, what I have to do? I have to apply force in a circular direction, no? I have to apply force like this. Are you able to understand? So my circumference will become 2 pi r. And what is the radius? Diameter is 1 centimeter. So radius is again 0.5 centimeter. But the circumference is only length, no? What is meant by A here? A means area. So what is the area on which I am applying force? On how much area I am applying force? To punch a hole. Into thickness. That's all, no? This gives circumference. Up to how much depth I have to apply this force? I have to apply up to a thickness of 0.5 centimeter. So length into thickness will give the area. Length into breadth, this area only, no? So circumference multiplied by thickness will give the area on which I have to apply a force so that I can punch a hole into this steel plate. That's all, no? So area is how much? Pi r. Radius is how much? 0.5 divided by 100 holes. 2 pi r, no? So 2 into pi into r. R value is 0.5 divided by 100 into thickness. Thickness of this one is how much? Again 0.5 divided by 100. So this is the value of force. So if you calculate this one, then 6.28 into 10 power 4 Newton. That is the answer. Okay. So Seema, this is the given question. So this is a cylinder on which we are applying forces in opposite direction and forces are equal. Clear, ma? And this is a plane surface. Plane surface means a circular plate. We are considering another plane surface which is at an angle of theta. So on this plane surface, we are supposed to find out these values. Clear, ma? So what is the tensile stress on this plane? Plane means this plane which is at an angle of theta. Clear, ma? Second one is what is the shearing stress? Third one is what is that angle for which maximum tensile stress is possible? And again, what is that angle for which maximum shearing stress is possible? That is the question. Okay. So all these values we are supposed to find out on which plane? On this plane which is at an angle of theta to the vertical line. Clear, ma? Come on. Think how you can do this one. See, ma, here, what is meant by tensile stress basically? Tensile stress means, so in forces, we studied two types of forces, no? Tensile forces and compressive forces. Tensile forces means which are responsible for elongation, increasing the length of a wire. Are you able to understand? So here he is asking that force which is responsible for increasing the length. That is force we have to take a perpendicular to the area of cross section which is given. Clear, number? For example, here, what is the area of cross section of this bar? Area of cross section is A, no? That's all, number. So which area of cross section is A? This area of cross section is A. Clear? So when bar is like this is the area of cross section, no? Its area of cross section is A in this condition. But we are not supposed to calculate answer for this plane. We are supposed to find out answer for a plane which is at an angle of theta. Clear? So if I consider them into straight lines, then how can I write? This is the area of cross section A, but we are supposed to find out about this area of cross section which is at an angle of theta. That's all, no? This is our original area of cross section. But this is the plane which is at an angle of theta. Then how can I calculate this area? Huh? F is not, if this area is A and this is angle theta, how can I calculate this area? A cos theta. See, this you can take to be x, no? Then here I am forming a right angle triangle. Then this x vector, how can I split? This is x sin theta and this is x cos theta. X cos theta is nothing but A, no? So A is equals to x cos theta. So therefore x is equals to A by cos theta. So this is the area. So x is how much? A by cos theta. Are you able to understand, ma? So if area of the given cross section is A, then area of the cross section which is at an angle of theta, that area will be how much? X is equals to A by cos theta. Are you able to understand? So this is the area of cross section. But to this area, how force is applied? Force is like this, no? In this direction. Clear? So if this angle is theta, then which angle will be theta in this condition? This angle will be also theta, no? So this force, how can I split? This I can split into two components. So this is the given force. If this is theta, then this angle is also theta. This angle, how can I split it? F cos theta and F sin theta. Okay. So this is our area whose area is equals to A by cos theta. And this force I have split into two components. Now, which is that component which is responsible for applying tensile stress? Is it F cos theta or F sin theta? F cos theta, definitely. Because this is the force which is normal to this area, no? So this force is responsible for producing elongation in this area of cross section. Are you able to understand more? So this area and this force we are supposed to take. Clear? Then he is asking stress, stress formula. Force per unit area. Force is how much? F cos theta. Clear, ma? Area is how much? A by cos theta. So total is how much? F by A cos square theta. This is our answer. Okay. So this much of tensile stress I have to apply so that I can elongate that area of cross section, or I can change the displaced position of that area of cross section. Are you able to understand? So which force and which area we are taking? That force and that area which are perpendicular to each other. That's all, Rama. Now comes the second question. What is the second question? Shearing stress. What is meant by shearing stress? Shearing stress means that force which is responsible for changing shape of a body. That is called shearing, no? And shape in which condition you can change? When you apply force tangentially. Okay. So this is my area of cross section, whose area is A by cos theta. To this area, which is the tangential force? F cos theta or F sin theta? F sin theta is the tangential force. So just divide both of them. Shows shearing stress is how much? Force per unit area. Force is how much? F sin theta divided by area is how much? Area is A by cos theta. So therefore shearing stress is equals to F by A sin theta into cos theta. Sin theta into cos theta, how can I write? Can I write it as F by 2A into sin 2 theta? Can I write like this? Because 2 sin theta cos theta is equals to sin 2 theta. But here I have only sin theta into cos theta, no? So I can take, I can multiply and divide by 2. It was 2 sin theta cos theta divided by 2. So this is my, what you call shearing stress, which I have to apply. Clear, ma? Now there is one more question also, third question. What is the third question? What is this angle theta for which maximum tensile stress can be applied? Clear, ma? So in which angle I have to consider this angle theta for which stress is maximum? Tensile stress is maximum. How can I calculate? This is the tensile stress which we have calculated, no? F by A cos square theta. So this value is maximum for which angle? When cos theta is 1, maximum value of cos theta is 1. So if cos theta is 1, then theta will be equal to 0 degrees. That's all, no? So therefore, F by A cos square theta is maximum at which condition? When cos theta is maximum, and maximum value of cos theta is 1. So therefore it is possible only when theta is equals to 0 degrees. Clear, no? When theta is 0, it means instead of placing this area like this, if I take area like this, then in this condition tensile stress will be maximum. Clear? Now what is the fourth question he gave? Now what is that angle for which shearing stress is maximum? Shearing stress means already we have calculated, no? This value. So this value is maximum for which angle? See, if this value is maximum, sin 2 theta should be maximum, no? And what is the value of maximum sin theta? 1. So my tensile shearing stress is how much? F by 2A sin 2 theta. Maximum value of sin theta is 1. So therefore 2 theta should be equal to 90 degrees. So therefore theta is equal to 45 degrees. That is my answer. That's all, no? For any where there is sin 2 theta, 10 theta, 20 theta, whatever it may be, maximum value of sin theta is 1 only, no? So here 2 theta is given. So sin 90 is 1. So 2 theta should be equal to 90. So theta is equal to 45 degrees. Are you able to understand? So therefore, if this area, it is present at an angle of 45 degrees, then the shearing stress will be maximum. Clear? That's all. Clear, ma? So this is the given question. So these two are similar voids. What is meant by similar voids? Their area of cross section is same. Similarly, they are made up of same material also. Are you able to understand me? So we are suspending two masses like this. One is 2 kg mass and another one is 1 kg mass. Then I am supposed to find out what is the strain produced in both these wires. What is the strain produced in this wire and what is the strain produced in this wire. Area of cross section and Young's modulus are given. Clear? Come on. Any idea? How can we do? So first let us take this wire, first wire. Clear? So in this wire, how can I calculate the strain produced? Formula for strain. Strain can be written as delta L by L. Clear? But here L is not given. Delta L also we cannot find out. Length of each wire is not given, no? Then how can I calculate strain? Young's modulus basic definition we know, no? Young's modulus is what? Stress divided by strain. This is called Young's modulus, no? Clear? From this can't I calculate strain? So strain is equals to stress divided by Young's modulus. Again, what is meant by stress here? Force per unit area divided by Young's modulus. Area of cross section is already given, 0.005. Now what about the force acting in this wire? Huh? M is how much? 3 kg, not 2 kg. Clear? On this wire, who is applying force? This body or this body? Both of them are pulling this wire, no? That's all. 2 kg body is also pulling this wire. 1 kg body also pulling this wire. So total tension developed in this wire is how much? How can I calculate tension? So this is the point of suspension, no? Total mass is 3. 3 into 10. 30 Newton is the weight which is acting. So therefore tension also will be how much? 30 Newton itself. Because mass is in rest position, no? So if upward force is 30, downward force also should be 30. So therefore what is my answer? So therefore strain is equal to force 30 Newton divided by area of cross section is how much? 0.005 into 10 power minus 4 divided by Young's modulus. Young's modulus is how much? 2 into 10 power 11. That is my answer. So calculate this strain. This should be our answer. Clear? Now what about second question? He is asking the same strain produced in second wire also. Now what about second wire? This is the second wire. No? Here how can I calculate the strain? Same concept, but only force is changing. In this wire, how much force is acting? Who is producing force in this one? Force nothing but tension. Who is producing tension in this one? Only 1 kg body. So tension will be only 10 Newton. Weight of this body is 1 into 10, 10 Newton. No? So tension developed will be 10 Newton. So here tension is 10 Newton. Here tension is 30 Newton. So again use the same relation. So again I can write strain is equals to stress divided by Young's modulus. So strain is equals to force per unit area divided by Young's modulus. Force is how much? 10 Newton divided by area of cross section 0.005 into 10 power minus 4 divided by Young's modulus 2 into 10 power 11. Then I will get the answer. That's all. So what are the answers which you should get? No. 10 power minus 4 for first one, 3 into 10 power minus 4 for second one. So that is, this is how much? 3 into 10 power minus 4. This is a 10 power minus 4. Clear? So those are the answers which you should get. So see. So a 30 kg hammer, it is moving with a speed of 20 meters per second. It strikes a steel spike. Clear? So with a speed of 20 meters per second, hammer is striking a steel spike or nail which is made up of steel. Clear? And after striking, it is rebounding also with a speed of 10 meters per second. Understand, ma? Then this total process is happening in how much time? 0.110 seconds. Clear? Then what is the strain produced in this spike? And Young's modulus of steel is given. Okay? Come on. Is area of cross section given? Not given. Come on. Think how you can do this question. Let us try a beautiful diagram of this question. So consider this is a steel spike and this is a hammer. Hammer will be very big. Wow. So this hammer is striking this steel spike and it is returning back also. Then I want to calculate the strain. Young's modulus is given now. So therefore, how can I calculate a strain? So Young's modulus is equal to stress divided by strain. So strain is how much? Stress divided by Young's modulus. Clear, no? So again, how can I write stress? Force per unit area divided by Young's modulus. Young's modulus is there. Area of cross section also I can calculate from diameter, no? Pi r square. By using pi r square I can calculate. What about force? So this hammer is applying how much force? This force how can I calculate? There is no information on force, no? Only mass of the hammer, initial final speeds of hammer. Huh? V is equal to? Any idea? Huh? No. From that you will get only acceleration. I want force acting. And force acting always depends on time also. Time. Acceleration is how much? No. No. Oh, in that method you want to calculate, huh? Okay. In that method I can calculate. See, man. So, immediately if you see velocities and time, what you are supposed to remember? Impulse. Impulse we are supposed to remember. What is impulse? Impulse is equals to force into time, no? Clear, no? Impulse is also equal to change in momentum, or mv minus mu. This we are supposed to remember. Clear, no? So or I can write m into v minus u. From this I can calculate force, no? So therefore what is the force applied by this hammer? M into v minus u divided by t. Okay. So therefore m into mass is how much here? 30 kg. Final velocity? Final velocity is 10, na? Final velocity 10. So initial velocity 20. So can I write 10 minus 20? No. Because velocities are changing directions, no? So if this direction of velocity, if I take positive, then opposite direction is negative velocity. Velocity is a vector quantity. So minus of minus, I have to write. So 10 minus of minus 20 divided by, and what is the time of application of force? 0.110. From this you can calculate force. That's all, no? So therefore can't you calculate the strain now? So strain is equals to force divided by area. Area of cross section, pi r square. So pi into r value. R value is 2.3 divided by 2 whole square into 10 power minus 4. So force per area divided by Young's modulus is already given now, 2 into 10 power 11. Calculate this value. That should be our answer. That's all, no? That's all. So force, how much you will get? 8.18 into 10 power 3. 8.18 into 10 power 3 Newton. And the strain which you will get is 9.85 into 10 power minus 5. 9.85 into 10 power minus 5. These are the values. So this is a frictionless pulley on which we are suspending a wire where two ends are connected to two masses. So this is 1 kg and this is 2 kg. Clear, ma? Then this is a metallic wire whose breaking stress is 2 into 10 power 9 Newton per meter. It means if I apply this much stress on this wire, then it will break down. Clear? Then what is the minimum radius of this wire such that this wire is just about to break down, or it is not breaking down just for that amount of radius? Clear? So if radius reduces then this wire will break down. So what is that minimum radius with which we can support this system? That is the question. Clear? Come on. Think how you can do. See, it is given that for this amount of stress, wire will break down. Stress relation we know, no? What is meant by stress? Force per unit area. That's all. Stress is already given, 2 into 10 power 9. Clear? Area of cross section. Area of cross section, wire is of which shape? Wire will be in the shape of a square, or wire will be in the shape of a triangle? Wire will be in the shape of a cylinder. That's all. No? Area of cross section of a cylinder, pi r square. That's all. No? So area value is pi r square. R value I am supposed to find out. Clear? Now the question is, what is the force applied in this wire? Stress I have. Area or radius I want to calculate. If I have force, then I can do this calculation. Now the question is, what is the force developed in this wire? Why force is developing first of all? Because of these masses. These masses are there pulling this wire, no? So because of this one, tension will develop in the wire. So that tension is nothing but force developed in the wire. How can I calculate tension in this condition? This is an Atwood machine, no? This is an Atwood machine. So for Atwood machine, for this condition, already we have calculated tension in Newton's laws of motion. Do you remember? What is the equation of tension in this condition? Tension is equals to 2m1 m2 divided by m1 plus m2. That's all. m1 m2 into g divided by m1 plus m2. From this equation, you can calculate tension. Clear? Once you know tension, tension is nothing but force, no? Substitute in this relation, you will get radius. Clear? Or if you don't remember this tension, then what can I do? Then you can use the Newton's law of motion, no? What is the first body? Sima. 2 kg body is a bigger body, no? This will move in this direction with an acceleration of a. This is a smaller body. This moves with the same acceleration upwards. Understand? So what are the forces which are acting on 1 kg body? On 1 kg body, the different forces which are acting is, one is tension, another one is weight, 1 into 10 Newton. That's all. No? Out of these two, which is the bigger force? Tension is the bigger force. That is why it is moving upwards. Then how can I write net force relation? T minus mg is equals to ma. Mass is 1, acceleration is here. This is maybe. So this is our equation number 1. Similarly, how can I write equation for a 2 kg body? For a 2 kg body also, tension is acting upwards. Weight is 2 into 10 Newton is acting downwards. But out of these two, which is the bigger force? 20 Newton is the bigger force. That is why it is coming downwards. That's all, no? Coming downwards with an acceleration of a. Then here, how can I write net force relation? Bigger force minus smaller force. So 20 minus t is equals to mass into acceleration. 2 into a. So this is my equation number 2. That's all, no? So if you divide both of them, a gets cancelled, no? Then I will get equation for tension. That's all, no? So how can I do? So dividing both the equations. So t minus 10 divided by 20 minus t is equals to 1 into a divided by 2 into a gets cancelled. So 2t minus 20 is equals to 20 minus t. 3t is equal to, I got 0, na? No, 40. So T is equals to 40 divided by 3 Newton. This is the force. This much amount of tension is developed in this wire, no? Are you able to understand? So take this tension, substitute in this relation, then I will get the answer. Tension is same, I got a, or have you done any mistake here? Same, no? Okay. Huh? Okay. Now you substitute in the relation, stress is how much? 2 into 10 power 9. Force. Force is nothing but tension, 40 divided by 3. So, divided by area of cross section is how much? Pi r square. Multiplied by, that's all. So, from this can't you calculate R value? That is our answer. So, what is R value? 0.46 into 10 power minus 4 meters. This is the answer which you should get. Clear, ma? That's all. Clear, ma? So, see this one. So this is a pulley, and where ropes are attached to supports. Length of this wire is 600 millimeters. Length of this wire is 900 millimeters. Clear, ma? And we are attaching a load of 10 kilonewton. So 10 into 10 power 3 Newton. What is the area of cross section of wire? 1 into 10 power 3 millimeters square. The Young's modulus of this wire is also given in terms of millimeters only. Understand? Then what is the deflection in this load? If I place this much of load to this system, then this wire will elongate, no? If wire elongates, definitely this load will move downwards. Clear? So deflection means how much distance this load will come down if I am supporting this type of system. Clear? 10 kilonewton. 10 into 10 power 3 Newton. Okay. Can you say how can I do? Okay, think for some time. Okay, see. So here, this is a wire, and if I attach this mass here, this mass will have some weight, no? Because of this weight, some force is applied on this wire. So because of this force, this wire will tend to elongate. Clear? For example, if I consider total elongation is 10 centimeter. Wire totally it has elongated by how much? 10 centimeter. Then this load will deflect by how much amount? Can you see? Load will deflect by how much? 5. Why it is 5? Because if this is 10 centimeter, if I consider this is also 5 centimeter, this is also 5 centimeter, then this will come down by 5 only, no? So total elongation divided by 2. That will be the deflection produced in this load. That's all now. That is the constant relations which we have studied, no? Are you able to understand? Now the question is, how can I calculate elongation produced in this wire? How can I calculate? So we have a relation, no? Y is equals to F into L divided by A into delta L. Then delta L is how much? F into L divided by A into Young's modulus. Young's modulus is already given. Area of cross section is given. Length is also given. Clear, ma? Then how can I calculate force? Force, how can I calculate? What is the total force acting on this wire? No. 10 kilonewton is not the force. 10 kilonewton is the force which is acting on this pulley. I want force acting in the wires. Huh? Again constraint relations only. See, this pulley is not movable, no? This is not moving at present. So therefore, what is the weight I am attaching here? 10 into 10 power 3 Newton. So this, if I call it as tension T, then how can I divide this tension? This tension I have to divide into T by 2 and T by 2, no? This is how we have done in Newton's laws. If this is T by 2, the T by 2. If this is 2T, this is T and T. So what is the tension in each wire? 10 into 10 power 3 divided by 2. That's all, no? So therefore, force acting in each wire is how much? 10 into 10 power 3 divided by 2 Newton. This is the force which is acting. Now can't you calculate elongation in the wire? Now on total wire, same force will be acting, no? Tension here also it will be T only. Here also tension will be T only. So on the total wire, tension acting is this much. 10 into 10 power 3 divided by 2. So therefore you can consider total length of the wire, no? Total length is how much there? 900. Here it is 600. So total how much? 1500 millimeters is the length of this wire. Clear? Therefore substitute in this relation. So delta L is equals to 10 power 3 force. Force is how much? 10 into 10 power 3 divided by 2. Length of the wire? Length of the wire is 1500 millimeters. Answer we are calculating in millimeters only. Because everything is given in millimeters, no? Area of cross section is how much? 10 power 3 millimeters square. And Young's modulus is also given in terms of millimeters. So 10 power 3 Newton per meters. So calculate this elongation, then I will get a particular elongation. How much elongation I will get? 2 into 3.75 mm. This is the elongation of the wire which I will get. Then what is the deflection in the load? Deflection in load will be 2 into 3.75 divided by 2. So which is equal to 3.75 mm. Okay.